Poisson regression provides more accurate estimate which controls for differential follow-up time between groups being compared. In order to compare rate, number of events divided by total follow-up time, we need to specify offset being equal to log of follow-up time. Cox regression provides hazard ratio, which is close to a rate ratio. In fact, in many papers, people use hazard ratio, which is derived on Cox regression. Instead of labeling their data as hazard ratio, they label their data as a rate ratio because rates are easier to understand than hazard. Poisson regression has an assumption. Mean of data is the same as the variance, and which is a hard assumption to satisfy, which is often true when you have very rare events. When you violate this assumption, then standard error may be biased. In order to account for this problem of over-dispersion, we use a technique called the generalized estimating equation, GEE, which can provide correct variance estimation even when there is a violation of this assumption. And SPSS has Poisson regression option and GEE option. But Poisson regression often gives wrong result because it doesn't have a way to correct over dispersion. And therefore, in today's example, we are going to use generalized estimating equation option for Poisson regression. And before we go to GEE, and let's create offset variable, which is log of follow-up year, transform compute ln fall year equal, right, and natural log of follow-up year. So natural log is ln, okay, and you put fall year here. And let's make sure that variable was created. Yes, it's created here. Alright, so now we are going to GEE. So go to Analyze, okay, General Linear Models, and go to Generalized Estimating Equations. And GEE is one of the newest form of regression introduced to SPSS. So they use a different format. So this involves 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 layers of specifying options. In fact, need to specify 1, 2, 3, 4, 5, 6 layers of those 10 layers. Okay. So this estimation EM means save and export. So in repeat button, and GEE is actually the popular regressions when you have repeated measures data. And therefore, we again will use GEE when we analyze repeated measures data. But today, we don't have a repeated measure. So we shouldn't be worrying about specifying repeat option, although with technical reasons, we need to specify ID in this box. Okay, this will not gonna do anything in terms of computation, but let's put ID under subject variable box. Okay, and since we don't really have repeated measure, we are going to ignore rest of the option. Okay, and next, type of model. And GEE is very capable model. Okay, by specifying options in the regression, it can be used for many type of outcome variables. Okay, so it can be used for continuous outcome variable. It can be used for counts, number of counts as outcome variable. Okay, it can be used for ordinal outcome variable, and it can be used for binary outcome variable. Okay, so today we are going to perform Poisson regression using GEE. So we're going to specify this option. And this response box, okay, we specify what is the dependent variable. You put the CHD fate variable, which is 1 if the patient has CHD and 0 if they don't. Okay, and that's all you do in this box. Predictor box specify type of independent variable. So when you put age 50 under covariate, SPSS consider it is a continuous variable. When you have a dichotomous, call it 0, 1, which is okay. But when you have categorical variable which does not have right order in it, or variable is ordinal categorical variable, and you need to put those predictor under factor box. And very importantly, and you need to specify offset. So put the created log follow-up year under this box. If you forget to do this, and result of this Poisson regression will provide risk ratio instead of rate ratio. And the models box actually tell SPSS which variable is included in the equation. Okay, so we have to put age 50, okay, put it under the model. And next one, I skip estimation, statistics box. And here, actually everything is checked. These 6 are already checked as a default. So all you have to worry about is checking this box. By checking this box, beta coefficient is automatically log transformed. So you can get the rate ratio. Otherwise, beta coefficient will be a log of rate ratio. So now we are ready to click OK. And this is the result of this Poisson regression. Exponential beta provides rate ratio, which is 1.979. So if you go to a lecture slide, which matched with our hand computation of 0.02195 divided by 0.01109, which is 1.979. We treated this as 2.0 because of number rounding. So let's see what happens if we drop offset of log of follow-up year. So let's go back to GEE, and that was under predictor, and get rid of offset. Okay, and we run the regression. Then exponential beta become 1.418. This is in fact matched with relative risk, which ignore follow-up time. So you can use Poisson regression with GEE when you want to compute relative risk. Although when you have binary data, popular choice of regression is logistic regression. So you don't really have to perform Poisson regression for relative risk. But sometimes, when events is rare, which is okay to use odds ratio as relative risk, although when the event is not rare, and using odds ratio to indicate increasing in risk, and you may mislead your finding. So therefore, it may be useful if you know how to perform regression for relative risk.